and this is Unit 1, Fundamental Definitions. Today we'll be looking at Section 1.4, what is Artificial Intelligence. Welcome to the course, and thanks for joining me. We know now from the previous lecture that machine learning is a part of AI. What else does AI comprise? Before we move on with data science and the rest of the course, we want to be able to appreciate what else is part of this burgeoning field that's been around since the 50s in the previous century. As always, before we looked at data science, we looked at data and science. Before we looked at machine learning, we wanted to look briefly at what learning was. And in this case, with artificial intelligence, let's look at what intelligence is. There's different types of intelligence. There's spatial intelligence that we use and animals use in navigating the world in 3 dimensions. There's linguistic intelligence, an expression of thoughts and concepts and emotions. Then there's an intrapersonal intelligence, understanding oneself and others, logical intelligence, quantifying things, formulating hypotheses, validating those hypotheses, existential intelligence, seeking answers to the questions, the bigger questions in life related to purpose, etc. And there's many more different types of intelligence, but again, because it's not part of scope, we'll limit ourselves to that and move back to a first definition of intelligence by simply saying that it's the ability to acquire knowledge and skills, the ability to maneuver environment, make the right decisions towards safety, achieving our goals, and even be able to set these goals for ourselves first. So it's a capacity for abstraction, logic, understanding, learning, reasoning, planning, critical thinking, problem solving, creativity, and so on and so forth. Let's take this with some examples to make it more concrete. When we learn to drive, we have to understand what the clutch pedal does, how to shift the gears, how to release it slowly together with the acceleration so that the car starts moving. After a while, this becomes abstracted so that once we're used to driving, we no longer think about gear shifting, and that becomes an abstracted part of the experience. And we're focused more on hazard perception out on the road through the windscreen by looking at what's ahead of us, what kind of risks and dangers lie ahead, what kind of situations can develop that I should be proactively seeking to neutralize and respond to in a safe manner. Similarly, problem solving. We need to be able to first understand what the problem is for us to be able to then devise a solution, maybe based off of experience. How do you reason? How do you learn? Have been the ambition and aim for researchers in AI to be able to replicate in machines. Intelligence of machines or software without explicit programming, the ultimate goal being general AI, the difference between general and narrow being goal setting, self organization, and sentience, for instance, machines that are able to set their own goals, organize themselves, and are sentient about what they feel, what they're thinking, what they want. This is a goal that, of course, has not been achieved. And what we essentially look at on a daily basis when we're reading progress and updates in the field of AI, we're more often than not looking at narrow AI, which is an application of AI to a very specific problem or an area of problems. In this case, we want the robot or the agent or some kind of a model to be able to process data, understand what the current state is from that data, be able to predict it and forecast in future to a certain degree of accuracy so that it becomes useful as a projection, and to be able to assist in processing large amounts of data accurately and extracting hidden patterns and relationships and highlight those to its human counterpart for collective intelligence between human and machine. So the distinction between narrow and general AI then is that narrow AI is focusing on knowledge representation, perception from sensory data, comprehension of it within a situational awareness architecture, planning, self-localization, the position of a robot within an environment, understanding what obstacles and objects lie around it, how does it maneuver, what's the map of the area and where it can move, pattern recognition, which is the main application area of data science for machine learning and AI, and natural language processing, computer vision, so on and so forth. But AI is much more than ML, and let's look at what else is there. As we have mentioned before, there's computer vision as part of AI because robots need to be able to process visual data to understand their environment. Natural language processing for it to be able to look at documents, understand commands from humans. Cognitive systems, robotics, perception, knowledge representation, planning, and so on and so forth. Let's deep dive into NLP and CV, in other words, natural language processing and computer vision, because these are more relevant to data science and AI from our perspective than the others, because robotics is outside of scope for this course. Or natural language processing, or NLP for short, is processing of text, using text to generate speech, spoken word, or processing speech, spoken word, and audio files to generate text and transcribe it, and to take documents in different language and translate it to another language. These are the main application areas of NLP, and there are plenty of techniques that are specific to this area, such as tokenization, lemmatization, which enable us to process unstructured text documents and feed those as numerical data or some sort of embedded data into neural networks or other algorithms for us to be able to classify, predict, and do other things with it. In this particular case on the slide, you see documents being pre-processed using some kind of NLP techniques, tokenization, etc., and then using different types of embeddings as well, dense embeddings. They are brought into a transformed state, which is appropriate and applicable for deep neural architectures. You see various hidden layers. The data is being converted or transformed into embeddings, which are then fed into the neural network. The output can be either classification of text, entity extraction, sentiment analysis, translation, and much more. Computer vision is the processing of image and video data. There are applications including object identification and detection, facial recognition, classification, ongoing monitoring, and so on and so forth. Intuitively, we need to be able to convert high dimensional visual data with, let's say, 30 frames per second. Even a small or a short video of a few minutes can be quite a lot of data to process for algorithms. So we need to be able to generate representations to enable processing from this high dimensional visual data to some kind of symbolic representation or numeric representation. In this case, we see an image of green apples. Let's say if it's a faulty apple on an assembly line or a washing line where packaging of fruits is taking place. And this CV solution, computer vision based solution, is used to single out apples that have gone rotten already or are damaged. Or it may just be a simple example of one image and the network needs to identify what object is in the image. So once it's pushed through and the fully connected layers within the neural network, we see on the far end, on the right hand side, the output could be a number of classes, in this case, the types of fruit, names of fruit, and the network detects apple as being the object that it sees in the image. And this brings us to the latest state of affairs, the current state of practice, and the current state of art being generative AI, which is also part of deep learning because it uses neural networks as well, in particular generative adversarial networks, or GANs for short, GAN. These kinds of networks create new content and they can create text, image, audio, video now in response generally to text prompts or some kind of a prompt. There are many examples out there. Generative pre-trained transformers, Llama from Facebook, Falcon large language model from TII in the UAE, DALI, Midjourney, Stable Diffusion, and so on and so forth. So a recap, machine learning is one of many fields now that are being borrowed from AI by data science. As we see here, not only are neural networks and deep learning uh, within machine learning being borrowed, but also computer vision and NLP are quickly becoming fields of artificial intelligence that are well within the remit of data science. And this list keeps growing every day. So to bring it back to the image that we had in the beginning, we have data science borrowing machine learning, which comprises neural networks, deep learning, and even GANs or generative AI. And we know that there are many other fields within artificial intelligence, two of which are also part of data science or being borrowed by data science along with machine learning, namely computer vision and natural language processing. On the left-hand side within data science, we have data mining as well. Data mining is essentially another term we need to define well in the next session. Data analytics, another one that we will take up in the next session. Big data and data insights. So data science essentially borrows the methods and techniques and algorithms of machine learning, CV, NLP, deep learning, generative AI from within AI discipline. It uses these techniques to process data or big data, to extract insights from data that are meaningful, that are actionable, that can be used by businesses to generate value either by reducing some uh, costs or increasing efficiency or increasing revenue and profits and so on and so forth. But we'll leave it here and take up the definitions within data science and these terms around data mining and data analytics. And then we'll look at business perspective on AI in this context in the next session. Thank you.